In this video, we're going to be covering all the basics of electricity, all the need-to-know ideas dealing with voltage, current, resistance, Ohm's law, drawing diagrams, and then basically just understanding all the main concepts and calculations to have a good foundation for understanding circuits and electricity. So first of all, we have three main components. We have voltage, I for current, and R resistance. So making sure you understand each one of those is going to be a key component. So voltage is the potential energy per charge. The current is the rate of flow of those charges, and the resistance is basically anything that is kind of opposing that flow. Now, between the voltage and the current, those have a direct relationship. So those rise up in a linear positive relationship. Between the current versus the resistance, that is an inverse relationship. So as the resistance rises, that current drops. So that brings us to Ohm's law, which gives us V over R equal to I. So as this voltage in the numerator increases, this current increases as well. And as this resistance in the denominator increases, the current decreases. Now, with that being said, that formula is going to be really useful, and it's going to give us a lot of different values once we get into our circuit. Now, taking a look at our circuit to the right, this is called a schematic diagram. So instead of drawing batteries and light bulbs and resistors, we're going to use symbols to simplify things. So with this long line and short line, this is going to be a battery, the positive and negative terminal. And then with the battery or any type of power source, it has a long line and a short line. The long line is always the positive and the short one is always the negative. Now, a lot of people do use conventional current. What conventional current is the flow from the positive to the negative with the old assumption that the positive charges move. Now, engineers and electricians do use the conventional current, although in most physics classes, the flow of electrons is the main focus of how a current works, which would be from the negative around counterclockwise to the positive terminal. Okay, so either way, whichever idea you use, the way that the electricity flows through and the way the voltage drops and the current flows is all the same anyways. Okay, so we're actually just going to work with a clockwise flow around our circuit over here. Now, in order for some charges to move, we have to have a high potential and a low potential. So this 12 volts is actually what's known as a delta V, a change in voltage. So it's really the electrons get loaded up with amount of energy that they're going to use throughout the circuit. The high majority of it they're going to use through these little squiggly lines. These little squiggly lines are resistors. Now, technically, those aren't the drawings for light bulbs, but a lot of times I'll just refer to it as something like a light bulb. The schematic for a light bulb or a lamp is going to be something like this, like a circle with an X in it, or a little loop with a circle around it. Okay, so I might refer to them as light bulbs, although those are technically the symbols for resistors. So we have a 2 ohm, 3 ohm, and 1 ohm rating for these. Now, as they leave and they go from high potential to low potential, they're going to flow through each of these resistors and take this single path around, which is known as a direct current, because they're going all the same direction. As I said, they're kind of flowing around clockwise and then kind of repeating that cycle going from high to low. Now, the thing about that is that as they use that 12 volts, ideally we're saying that they're not really using any energy in the wires, but they are probably using a very, very small percentage. But for them to move through the copper wires is pretty, takes very little of their energy. So we'll just say 100% of it goes through the 2, 3, and 1 ohm resistor. So the way you would figure this out is you would take a look at the total resistance of the entire circuit, which is pretty simple. We have a 2, 3, and 1 ohm resistor. So if we want the total resistance, we just sum those up. And then we have 6 ohms total. Now, all three of those together sum up to a total resistance that controls the total flow or current of the entire circuit. The reason being is we could say the electrons are in bumper-to-bumper traffic. So if the electrons are slowing down over here at the 3, then everything behind them is going to slow down, and then same thing behind the 2, and then same thing behind the 1. So they're all in the same loop, they're on the same flow of traffic, therefore all of the resistors are impacting all of the electrons within that circuit. Secondly, we're going to take that 6 ohms and Ohm's law, and we're going to say it has a total voltage of 12 volts divided by that 6 ohms, which gives us 2 amps of current. Now that 2 amps is going to be consistent throughout this whole entire circuit. So it doesn't matter where you are in the circuit because it's a direct current and it is a series circuit, which means it only has one path for the electrons to move. We are going to have 2 amps of current everywhere flowing through each of the resistors and the actual voltage source itself. Now, each one of these resistors is going to use a portion of that 12 volts. And what we can do is we can do 3 minor calculations by taking the R and multiplying it to the other side, and then saying V is equal to I times R. Now, if we did that, we can find the individual voltage drops for each one of the resistors. So let's go ahead and do that. All right, so now I found the voltage drop that each electron experiences as it passes through each of these resistors. So I color coded them. So the one in orange, all of them have the same current, experience the same rate of flow of electrons passing through, and each of them have the different R values. So all you have to do is find the product of the current and their individual R values, and we got 4, 6, and 2 volts. Now the final step I'm going to do is sum those up, and if I do 4 plus 6 plus 2, I get 12, which does match up with the original 12 volt rating of my power source. So that's one final step that you definitely want to do. All right, so I rearranged some things to clear up a little bit of space, but if you wanted to find the power output for any one of the resistors, and like I said, we'll just call them light bulbs, that would show you the brightness of the bulb. And you could find that a couple different ways. I would say the main formula that I typically use is IV, I being the current and V being the voltage. So it's kind of like the amount of charge that's flowing through, and then how much energy per charge is dropping through that particular bulb or resistor. Also, you can rewrite this as power equals current squared over R, or excuse me, times R. And what you're doing there is you're basically just doing a little bit of a substitution and then replacing this V with the I times R, and then that would be I times I, which is I squared, and then put the R next to it. Either way, you're basically solving for the same thing. And then you would find the power in watts. Okay, and that's how many joules per second, how much energy is being released per second by that particular electrical component. So if you wanted to do that for each one of them, you could easily do that because you already have all of the numbers available. So say, for example, for this 2 ohm orange resistor, you have the current of 2 amps and you have the voltage of 4 volts. So it's pretty simple. Find the product of those two and you have 8 watts. And then same for the other one, 2 times 6, 12 watts, 2 times 2, 4 watts. Okay, so you'll notice that the ones that produce the highest brightness are the ones with the most resistance. The ones with the most resistance will cause the electrons to have the greatest delta V, the biggest voltage drop. So if it has the biggest voltage drop and the same amount of current, then of course the product of the I and the V is going to be the greatest and then give you the greatest amount of brightness as well. So I hope that was helpful in helping you understand some of the foundational ideas of electricity and circuits, as well as taking a close look at a series circuit and doing a bunch of calculations with it. Thank you for watching and listening.